something J, SJ, SJ.
Very easy. Just landed. Say your number.
11. It was 11-8. He was way low.
What was it?
A couple hundred feet.
11. Just landed.
11.
Say your number.
SJ. 11-8 SJ. Thought about it. A couple hundred feet long. Yeah, it was 118 SJ.
What, 118?
SJ.
Okay.
Well, they were coming fast and furious. Short final series. Somebody inside of those two to beat it?
Yeah.
Hey, how you doing, man?
Good, and you?
How's that plane?
Ready to roll it out this week.
Is that right? Really?
Guys, you gonna try?
To give Camarillo a week from today.
God, what a squirrel. You good, Sam? Everybody's home. You guys get a chance to get your spot on this? Really good. Why? Pretty good.
23 something?
I'll get it read it.
23 RA maybe.
Mojave traffic. What's up? The bus usually up to 21.4.
A month ago, I noticed altogether there's 5 hours in it. It's been a month. It ain't, I don't even have, I didn't do what he said. I put these on first. Now I'm going back. Okay, where the damn
Trish Palmer. And this is good. I want to take a little survey of you first, and then I'm going to kind of summarize what we're going to do today, and then turn it over to these guys to get started. Well, first of all, let me summarize what we're going to do today. There's going to be 2 hours of good, hard, intense construction workshop going on here from as soon as I shut up until about 12:30 or so. Now, the thing that's different about this is we're going to concentrate on the things that are new since we gave the last workshop, and we're going to give a full workshop on finishing. And finishing has always been something that we've never really done well in the workshop before. We've just left it to the last and never gotten to it. So there's a lot of new products that have come out in the last year or two, or being used in the last year or two, and Mike and Michael are going to go over the finishing in some detail. There'll be an air show at lunchtime, and then at 1:30 we're going to do something else that we haven't done in a long time. We did test the Ultimate of the Canard way back in the early days. I'm talking 1975, 74. We've done tests to limit a whole bunch of times, and but today we're going to do 3 Canards to Ultimate. So we're going to make some noise today. Now, the Canards will be loaded with shot bags. One of them is strain gauge, so we can measure the actual strain of the fibers in the critical areas, which is the top cap. And we'll be setting up the electronics to do that. Also measuring a tip deflection, and we'll see how these go. Now, the Canards, the first one we're going to break is one that is a reject. A fellow brought it in here knowing that he had done inadequate work on it. It was obviously not good enough quality, and we agreed with him, and he left it here. We told him someday we'll do a static test on it. That's the one that's mounted. There's no finishing work on it. And if you get a chance to mill around, you can see that the lamps are way too dry to be acceptable. That we'll take to Ultimate. The next Canard we're going to test to Ultimate is the one that's on my Long Easy. It's been on my Long Easy for most of its flying. Guys, some of you are familiar with it, but we have about 5 Canards. There's still a couple of them in the back room here that we've tested. There's 3, I think, still in the back room that we've tested working out a more optimized airflow for the airplane. So the next one we're going to break is the original Canard is GU section out of the basic plans that's been on 79RA, and it's been through a lot of aerobatics. So we're going to see today how much margin we had left in it. The last one is also, let's see, what's the last one from? It's a standard Canard. Oh, okay. The last one is a standard Canard off Mike's airplane. And what we're going to do with that is we're going to damage it first. And we're going to use the standard procedure for damage that's used in the industry, and that is to take a 3/4 inch spherical steel ball on a 2-pound weight and put increments here of let's lay that thing down. Every one of these nail holes and so on is another foot-pound of energy, and you can pull that out, and it puts a certain amount of energy into there. We'll go over in detail. I'm not going to spend time with it now, but we'll go over in detail just how much damage is supposed to be put on it. We're going to damage it and then see in the failure test how much it destroys its structural integrity. If any of you want to volunteer your airplane for the damage demonstration. Okay, now, I wish we could open up this whole area because it's much cooler back there than it is in here, but Mike won't let me. So, I would like to get, now that I've got a decent group together, get an idea of what you guys would like to see next. And I want to take kind of a survey of what you think. The only 2 things we've done in the last several years is Voyager and Solitaire. So I want you guys to give us an idea if we've selected the right group to go into. How many out there would like to see an 8-place hovercraft? Okay, the supersonic ornithopter group. High-speed, high-performance 5-place that will go into grass fields. No? Well, give me suggestions there. Is there none?
4-place long easy.
Okay. Do you want it pressurized?
4 and a
I
half.
want one that's about half the work to build as long easy. And the 4 or 5 place, about 180 knots and 250 knots turbocharged. Nobody? Yeah, okay. And lower cock. And 3 engines. Does anybody have, really, I'd like to get your ideas and your suggestions. Frankly, we made a mistake on solitaire. We put a lot of effort into it, a lot of money into the development, really more than we did on any of the easies, and it's been a failure in the marketplace. Frankly, there's just been a very few number of kits sold and a very few number of plans sold, and it has not been something that we should have done. So having that behind us, that failure, as it were, behind us, even though it's a nice flying airplane, it hasn't been for us financially a failure. Having that behind us, it's really tough to decide what to do. So we do need ideas and your input to assure that we're doing the right thing. Okay, I'm going to let Mike bring you up on an update on what's happening at RAF lately. We'll have another newsletter out in early July. It'll be out a little early this time. And any inputs that you guys have that are builder things, or any inputs that you have to the newsletter, do get them in the next week or so for the July newsletter. At any rate, stick around for the Canard tests. They're going to be interesting and exciting. We hope not real disappointing. We hope we got at least 1 G margin on the one we've been doing aerobatics with. And I'll be running that, so I'll be talking to you later. But now I'm going to turn it over to Mike and Michael and get on with the workshop. Does anybody have any questions before we do that? Oh, I wanted to introduce my bride too, Margaret and Sasha. I got married last November. Okay, thank you very much, and I'll turn it over to Mike. Oh, I forgot, yeah.
Okay, before we get any further, the fuel availability on the airport will cease at 4 p.m. this afternoon. So if you need any gas, put your order in to Trish or to Sally or somebody. You can make a call down there, or catch the gas guy and he's driving around in a truck. There is no pumps here, just a gas truck.
If we could do that around about lunchtime and have him come up and do all the airplanes at one time, it's going to save them a lot of hassle.
Right, okay, so lunchtime would be a good time for that. Anybody who may not have closed the flight plan, for God's sake, get it closed. Get it into Trish and have her call it in. We have that every time we have people that don't do that. If you don't have a raffle ticket, you can win this propeller here for $1. So if you don't have one, make sure you get one. There are also free tickets in there for door prizes, and we have quite a few door prizes. So you want to make sure you get those tickets. I guess that's out of the way. We'll have a go at this thing. What we're going to do is we're going to cover real quickly, because most of you guys are fairly familiar with this structure. We're not going to beat on the dead horse like we've done every time. We've always gone over the same old things. We do have to, though, for the people who've never seen it, we do have to quickly go over hot wiring, basic layout.
There's one more door prize on the way, and so it was just brought in and to be at the desk.
That's one of the door prizes, and it's a scale model, very accurate desk model of a Long Easy. Anybody who would like to take a look at that, it's a beautiful model. The basic layout thing, like I was saying, we'll go over that quickly, and we're not going to be able to stop and handle a lot of questions. So the best thing to do is, if you've got any questions or anything really bugging you, write it down and try to catch us after this thing. We don't have a hell of a lot of time, and we want to try to cover all of it. After the basic layout, we're going to do the new Canard for the Long Easy spark cap layout. a demonstration of how to lay up the spar cap on the new long easy spar. That's buttercup. So that's what we intend to do. We're going to use, for templates, the new Canard template, which is, compared to the old Canard template, quite different. That's a GU, and this is a Rance Canard. The water lines are very different on them, and if you overlap them, the way they go, that is how they look. Well, I should have put them, I guess this is how I like to do it. So you can see there's quite a considerable difference in the shape of the thing. Come up afterwards and compare it. They're very, very different. This one has no trim change in the rain, and this one sometimes does. Sometimes has a bad trim change. So we'll quickly do us a hot wire cut of a Canard using these templates. If you're going to build a new Canard, you may be interested in this because you cut out all of your Canard parts, foam parts, using this shaped template until you have all the parts cut out. And then you go in there with a template that looks like that to cut the troughs. When you do that, you don't end up with rounded corners in the bottom of your spar trough. So that is a method that we recommend, and that is what is in the plan. The plans, by the way, are for sale in there. Anybody who wants them, we've got plenty of them. A little level. So the most important thing when you're hot wiring a block is the weight that goes on it. The weights that go on it, they don't have to be lead shot bags, but anything that's heavy, bricks, lumps of lead, put them right at the end of the block. Absolutely no good at all to put the lead in the middle of the block. Because when you're cutting and you're holding the wire up on the template, you're going to lift this end of the block. And when you lift this end of the block, your wing looks like this. So you must have the lead or the weights right where the template is. And if you're cutting out something like we're doing, where you make one cut around this, and then substitute this and make another cut, you do not move the weights or the foam in between. If you move it, you've got to start again. Because there's no way that it's going to be exactly right unless you're on an optically flat table and you have a flat foam block. And we don't work with perfectly flat tables here. I don't know about you guys. A little level. There's a water line on these. The water line should always be level. Always. All water lines are level. No matter what they are, they're always level. The same water line anywhere in the airplane is level to all the rest of the water lines with that number on it. Some people didn't know that, but the oceans are always at the same level. Water line. The new Canard, the 1145 Rance Canard, has a lot of positive incidence. The old Canard only had 0.6 of 1 degree of incidence. This one has 3 degrees of incidence. That's a lot of incidence. It sits real steep. Put it on there with a level and pin it to the side. And when you get one side done, measure up from the table or down from the top of the block if the block's an equal height to get the other one so that both templates are the same height above the table. Obviously, if you had them way off, you're going to have angles at the ends of your foam that won't match when you glue them together. That applies all over the airplane. Of course, these are AN nails. What we do, we get the finishing nail and we sand a sharper point on it, on a sanding disc or a belt sander, and sand these little serrations off. Just make yourself up a dozen nails so that they don't catch and hang up. Now what we have here is we have jig drilled or clamped them all together, all of the Canard templates. And we made them out of Formica. Just went down to the lumberyard and bought some scrap Formica and made them up. Some people seem to think that maybe we've got laser cut, dead accurate templates here. Well, you're welcome to look at these. I made them myself. They were made in just a few minutes. you know, they're reasonably accurate, but they're not something that's right down to an nth of a millionth of an inch. There's no need to get that carried away. I know some guys are out there trying to spend 2 weeks making one damn template. That's foolish. You should be able to make all your templates just in a little while and not waste time. You should be building the airplane, not the jigs, fixtures. You know, accuracy is fairly important, but not down to thousandths of an inch. When you're working with foam, thousandths of an inch are things you don't even think about. All of the holes that are in these templates, though, match each other. So when you go to put, we've got a dud AN nail there. Okay. This is the hot wire saw that we use. It's just a 2x4. We wrapped some fiberglass around the end so it wouldn't split. Drilled a couple of holes and put some heavy wall tubing in there. That's not just conduit, that is 4130 tubing. The reason is that conduit is unable to hold the tension that you really need. It'll hold for a while, but we use them quite a lot here, so we went to the expense of a piece of 4130. But it's a real simple tool and you can make it in just a little bit. You don't need to get too carried away with the hot wire saw. The purpose is that your variac, and you can see we have the very latest model here, it simply heats the wire up to a temperature that is below red hot. This thing should not be glowing. Just enough that it'll cut the foam at a rate of 1 inch every 4 to 6 seconds. And what we normally do is just take a piece of foam, hit it on there, and count 1, 2, 3, 4, 5. That looks good. And then we go for it. Again, it's not something you have to be dead right and absolutely accurate. Practice with it. Get some scraps of foam and practice cutting. Foam cutting is easy. Having to go out and buy pre-cut foam cores for a lot of money, to me, is silly. Because your girlfriend or your wife or your kid can help you cut it, and you can do every bit as good as they can. Because those foam cores are not computer cut. The fancy computer cutter didn't work. They've got 2 guys like Michael and I cutting those foam cores. And of course they've done a lot of them, so they do a pretty good job.
What wire are you using?
We've got 50 thousandths wire on this right now. And it's just stainless steel safety wire. We have found that the real fancy, what the hell they call it? Nikon. It tends to break. It's not very ductile, so if you tighten these up to the point that it's almost at failure, and you're in the middle of cutting and it breaks, you ruin your foam core, because it curls up inside there while it's still hot, it destroys the foam core. So the stainless steel is very ductile. We've had this piece on here for 2 years. Same piece, and it's never been replaced. In fact, maybe 3 years. It's been a long time. If it breaks, we're out of business because it's the only one we got. Are you ready? Contact. Let's just cut it through the corner here and see what we can do. Lift up there. Just cut a corner out. Turn it on? Not turned on, right? Plugged in. It is plugged in. Not at the other end. That's important.
Who's sitting up there?
Okay, we're just checking the heat of the wire. 1, 2, 3, 4, that's about an inch. Let's come out straight and horizontal. Okay, that's about the right speed right there. Again, it's not a critical thing, but you are looking for maidenhair right here. See this? That's what we call maidenhair, or angel hair. That's what you're looking for. And if it doesn't pull hair like that, you've got the wire too hot. Okay, if you get no hair at all, the wire is too hot and it will crater the foam. The surface of the foam will have a lot of burned craters in it. And that is not as good as if you get a lot of hair hanging off it like that. Now generally you will always start a hot wire cut at the leading edge of an airfoil. The reason is that if you start at the trailing edge and go around the leading edge, that you will get lag. The center of the wire is not going as fast as this end of the wire. And it lags behind, so it shorts you in the center of the airfoil. Start at the beginning. The way that I like to start is to put it on the nail on the leading edge and then turn it on. If you turn it on out here, let it get hot, and then go into the foam, it tends to be hotter than it would have been if it was in the foam. So it quenches itself as it goes in and loses some temperature. But as it does that, it destroys your leading edge, which is the most important part of your airfoil. The first 15% of the leading edge is really the critical part of your airfoil. So put it on the foam, have it sitting on that nail, and then turn it on. Let it warm up while you're sitting there. And always know that you're going to go around the top or the bottom. You don't want to be doing opposite. Okay, we're going to go around the top this time. It's starting to go in. I'm sitting on the nail. We're up against the template. We're going to go up. You ready? 1, 2, 3, 4, half.
Phone's ringing. Let me get it.
Half. 6, half. 7. If the phone rings, the hell with it. 8. If the postman comes to the door or anybody, just ignore him. 9. And if Burt tries to hassle you, you've got to ignore him. 10.
Down here, he doesn't know how it's going.
11. Yeah, you give us a...
Down here, he doesn't know how it's going. He's the only one that knows. He sees his side and he hears that side.
13.
Mike doesn't have any idea, but Michael knows.
14. You always want to put the idiot on the side that's counting the number. 15. The low experienced person should count. 16. If you're doing a tapered wing, the low experienced person should be on the big end.
We have checked time and time again,
18.
and it won't go through a net.
19. 20. No, we don't need to care about this one. 21. Want to go up? No. 22. Better not to pause at that point. 23. 24. If you stop at that point, you get a line in the top of your wing. Okay, we're starting to come out. Now, it's important when you come out that you stop on the edge of the template. I'm about to break out. I've stopped moving the wire. Now we're off. Good. Look at all the hair. That's a good one. Yeah, the temperature is about right on that. Now, don't move anything. God, don't get excited and jump in there and move things now, because if you do, you just take that foam block and use it as a doorstop or something. Nothing should be moved. Now we're going to go and we're going to cut around the bottom of the airfoil without moving the weights or the foam. You ready? Okay, we're going to be underneath the nail. Again, let it warm up on the foam. It'll move in slowly as it warms up. I'm going under the nail. Oops, I'm going to be in trouble. Make it out. Okay. We should. I'm going to run into something. Okay, why don't we just leave it at that, and we'll do the top slow. Okay. We don't need to cut it. Yeah. I've done that. Okay, now that's a classic thing that can happen to you. You need to be sure that you're hanging off the end of a table. Ordinarily, we have this across our table, and so our hot wire saw would be able to go through without striking the table. Now, if you have a problem like that, that is a big problem, because now you've got to move your foam block and get it twisted, and where it doesn't go back exactly where it is, you're not going to have a usable part.
If you're cutting a piece that you don't have a table that's the right length, you can stack a couple of boards under it before you put the weight on.
Yeah, or another foam block.
Lay your turn the cutter,
Yeah, you can turn the saw down. For this demonstration, though, rather than waste time, look at it. We're going to leave the bottom, and we will now cut the top spar cap using the templates out of the new Canard and the new method. These tail leads on, you have to change them, right, to get from a left to a right. If you put them both on, when you cut both of your center cores, if you put these on just the same way, which is, believe me, very easy to do and has been done many times, you have 2 left hands or 2 right hands and you're going to have to trade with somebody. By the same token, if you're doing a tapered wing, like a main wing on a long, okay, we're making a part of the template that's going to drop you in. Come across the foam block just underneath the circle. Stop right above it. When you're both ready, start on down and start counting numbers. Now, in order to get sharp corners in here, we're going to pause in the corner. We're going to come on down. We're going to pause for a count of 1 or 2 seconds. And then we're going to continue on. Pause 1 or 2 seconds, and then come out, and then don't go through the lip. The reason for that is to try to get a very square, very straight spar trough. The better your foam core is, the better your part's going to be. The foam core is everything. If you have a screwed up foam core, it is very, very difficult to make a nice wing. Foam core is very important. Okay, we ready? Okay, you better count this time. He's going to have further to go than me because his is a deeper trough. Anyone who's going the furthest distance, the bigger end of the wing, should be calling the numbers. Or the lower experienced person calls the numbers. Okay, we're ready to go. Okay, it's starting to warm up. It's going to move through the foam nice and slowly. I'm about 2 inches from where we've got to be. It's a good idea to call the distance. Tell the other guy, okay, we're 1.5 inches. You know, then he knows.
Yeah, I'm still 2.
You're still 2, so I'll slow down a little bit. Okay, you call the distance.
About 1 inch.
About 1 inch. I'm looking at 1 inch. That's good.
Okay, 1/4 inch.
1/4 inch. Boy, that was fast.
Well, I'm moving it here.
Okay.
Right, I'm on it.
You ready?
Yeah.
Okay, I'm ready.
Go.
Go down.
1, 1/2, 2, pause.
1,
Go.
2, go.
1, 3, 1/2, 4, 1/2, 5.
My job to keep up with him.
6, 1/2,
Slow down just a little bit.
7,
That's good.
1/2, 8,
8. Good.
1/2, 9,
Perfect.
1/2, 10, 1/2, 11.
Start slowing down a little bit. We're in the
12,
corner.
In the corner, pause, go.
Go. Going up.
13, 14.
Okay, clear.
Okay, out the back.
Okay, now we just continue just to eyeball it. No big deal, you know. Just let that foam trickle on out the back end. Don't cut the fishtail off your airfoil though. Yeah, 1/2 inch from the edge. 1/4 inch. Start to come out. Okay, that is the hot wire demonstration. And what we have now, we will assume that we've completed, and we can now take the weights off. We can now look and see how poorly or how well we did. Well, we can leave those down. As you can see, we have lots of hair, lots of angel hair, and we have a real nice cut. There's not much cratering on that at all. We'll leave it here for people to look at. But you can see we have a very nice straight trough with very straight, sharp corners. So you can just go right into that and do your layup. Now, ordinarily, of course, we would have cut the bottom first, and this one is just a sample. What will happen, though, where this nail is at the leading edge, you're going to end up with flash here. That you need to dress off with a sanding block, and that you need to do very carefully. You do not want to damage the shape of the very leading edge of the airfoil, because that is the most critical part of the airfoil. So take a sanding block with about 40 grit on it, and just very carefully sand the flash off. Break it off with your fingers first. Just bend it back and forth till it breaks off, and then sand just the littlest bit until you have a nice smooth round leading edge. Do not sand any of the base foam off, because then you've got a new airfoil. It's there for anybody to look at.
Basically, we're going to do a basic layup. This time we're going to do one on to Pledgicel. And we'll do a 2-cross plastic uni, slurry the foam, remember to slurry the foam, and a half-flat bid, which we use in different places to apply the edge. We're going to go through it fairly quickly, and anybody, basically we're going to do a fresh layup, and anybody, as soon as we're done with the project here, actually when we're done with it, we can pass it around or something so you can see it. That's about all that there is.
And some of the equipment that we're going to use, this box is just a plywood box. It's not insulated or anything. It has a light bulb in there. What is it, 60 watt, 55? Yeah. It has an attic thermostat wired into it, and it will hold this epoxy before it's mixed. The resin and the hardener are separated in a pump in there. We keep it at about 100 degrees. In the summertime, the bulb never comes on. In the wintertime, it's on all the time. But this is one of the Michaels pumps. And feel free to come by and look at it. Nothing special about it. The box is big enough we can keep our 5-minute epoxy, or they call it 4-minute anymore, as well as an extra gallon jug of resin, a gallon kit of resin and hardener can be kept in there. And we just fill the pump from warm water. That really will help you. If you've got your pump sitting out in the garage without anything to keep it warm, your epoxy is very cold. It sits there overnight. The damned resin and the hardener are cold and it's hard to work with. When it's 100 degrees, it's nice and thin, it mixes easily, and it goes on and wets out real well. Hey, Michael's using a little hot stuff, which is a cyanoacrylate glue, instant glue like crazy glue, to just tack that foam block down on the table. If you're doing a flat surface foam, like this would be your front seat bulkhead in a long easy or a very easy, or your back seat bulkhead, or the sides of a long easy fuselage. This is the material you're going to use. It's PVC. This particular stuff is Pledgicel. We are using more of the Divinicel nowadays, which is exactly the same material except it's tan in color. But it is a PVC foam. It's very strong, and it has excellent peel qualities. The peel quality between the epoxy joint between the glass and the PVC foam is very, very strong. So it gives us an extremely strong edge rating and good crash worthiness. This is the latest product that we've been into, and it is really something super. Spruce and Wicks have this material now, PR88, and it is a hand cream, a barrier cream. It's very nice stuff to use. Put a little bit on your hands, rub it all over you before you get the epoxy on yourself. Or paint, or anything. If you're working on an engine. Yeah, Larry, you should get a can of that. And it's amazing how you can just wash your hands with soap and water. The thing that I like about it over some of the other products we've tried, when you get it up on the hairs on your arms, it doesn't plaster them down and stick them to you, like some of Flyin does that. It's uncomfortable. This stuff doesn't do that. It dries very rapidly and you don't even know you've got it on. I personally don't use gloves, and that's probably not a good thing. I'm not advising you to do that. Michael has been quite a stickler for using gloves until we got this new product in here. He's used them on every lab. But it's a good thing. You need to protect yourself. This is an industrial quality material, and safety epoxy is supposed to be one of the best as far as toxicity. However, it still does have the propensity to get, if you have a possibility of an allergic reaction, you can have an allergy reaction to this stuff. It has very low toxicity, almost out of water, but it still has stuff in there that some people are allergic to. Now, I'm not. I've been using it since the first batch they ever made. I did the first test layout with safety epoxy, and I have never had any kind of reaction to it. But that doesn't guarantee that you won't, or that I won't. You know, you can have it at any time. What it is, it slowly gets into your system until you reach a tolerance level where your body says, that's as far as you're going to go, guy, and you break out, or something will happen to you. So if you don't want to do that, protect yourself as much as you can.
Notice that we do actually cut the sticks off. I've had some skeptics about that. We're mixing. We do pretty much what's in the plans, the way it's called out.
Okay, Michael's mixing slurry. Slurry is epoxy, and epoxy is resin and hardener in the correct ratio. Epoxy is not epoxy until you put the resin and the hardener together. When it's together, now you have epoxy. And it goes off by a thermal reaction. It gets warm. So you don't want to waste too much time. He's mixing an equal volume of foam of micro balloons or microspheres, glass bubbles, whatever you want to call them. They're made by 3M. You can get them from either of the distributors. You put an equal volume of microspheres to epoxy. That gives you slurry. That's a runny, honey, a little bit less than honey consistency mixture that you're going to pour down on the foam. You're going to squeegee it into the foam. The purpose of it is to fill all the broken cells that are the surface of the foam. The surface of the foam, this stuff is grown. They mix up some chemicals and they grow it in a vat, and then they saw it into boards. When they saw through it, they break all these cells. These cells are separate from one another. This foam is not porous. He pours it on there. He's got it a little bit thicker than what you really want. But that's okay. Squeegee it on there. You're not putting it on like peanut butter. And what you're trying to do is fill the broken cells on the surface. When you get those filled, what that does for you, it gives you a nice smooth surface for your glass layout. If you don't fill them, the epoxy you put into your fiberglass has to go down into those broken cells and fill it. And epoxy is heavier than slurry. The purpose is simply to save some weight. If you don't slurry, you can end up with just as much strength, but a heavier part. And it'll take you longer to do it, believe me. See, he's spreading it out, filling all the voids. But he's not leaving it pasted on there like peanut butter on a sandwich. If you've got any damage to the surface of your foam, that's not a big deal. You can mix up a little more micro balloons into the epoxy and make dry micro, fill the damaged spot, squeegee it off smooth, and do the layup over it. Now, if you get a lot of damage all over it, you're going to wind up with a heavy part.
Okay.
That's what it should look like.
That's what it should look like, which is you've got the blue coming through. You shouldn't have any areas where it's all micro piled up on top.
If it's solid yellow, you've got too much slurry on it. Looking good. So what are we going to do? 2 lines over here. Okay, we're going to simulate a front seat bulkhead on an easy, either one, very easy or long, or the sides of a long easy, which consists of 2 crossing plies of unidirectional fibers. Unidirectional fiberglass is just that. The major fibers run in one direction. The minor fibers, which are only 5% of the total, run across and keep those major fibers in line, and we do not count the minor fibers in the calculations when we're doing a stretch analysis or a stretch calculation. So unidirectional, one direction. And the direction you put it on the part is important, and it's called out in the plan. Don't fiddle around with that, don't change the direction. If it says put it on at plus or minus 45 degrees, it doesn't mean you've got to be exactly 45 degrees. An eyeball 45 degrees is enough. But you don't want to put it on at 90 and 0. Because now you're not taking the loads in the direction we want to take them. And we have carefully designed the thing so that the loads will be taken in the direction the fibers go. So that's very important. We're going to do a layup of 2 crossing plies of uni, just like it was a front seat bulkhead. And then we'll put some bidirectional cloth on just for those who haven't seen it before. Bidirectional is just what it says. 50% in one direction, 50% in another direction. When it comes off the roll, it is woven at 90 and 0. Obviously, it's pretty hard to weave it at 45. But we always cut it so that the fibers run at 45. In other words, when you roll it off onto your table, I like to mark the table 6-inch increments with a black felt tip marker gun at 45 and at 30 degrees. That way you could roll it off, take your scissors, and just cut right down one of the lines, and you'll be where you have a sheet that looks like this, that the fibers are running corner to corner. And the reason for doing that is so that you can move this stuff and mold it around a funny shape. If you have it at 90-90, and you're trying to go around a corner, you will find...
See how much we sand before we put the material on. This is a sterling, which a lot of you are familiar with and have been using. You notice that after you sand the sterling, there's a lot of spot cutting that goes on. That's one of the reasons that we think some of the other materials might be an improvement. This is a problem with the sterling. The particular qualities of the material, I've done my best to lay out how we feel about the working qualities up on this board. We'll come up and look at that. If it's not clear then, then come and ask and we'll answer the question. After the spot putty goes on, then we sand it. I put 2 coats on here because I never get the primer in 1 coat. It's just the way it goes. We've sanded the primer with 320 and then quickly scuffed it with 400 and put on DuPont Centauri, which is what the 79 Romeo Alpha, the prototype long easy, is painted with. The Solitaire is painted with the same type of paint in a Ditzler brand name. And that material recommends 400 grit.
Have you guys heard anybody having any luck on the initial sanding, instead of sanding using bead blasting?
Yeah. If you have the capability of doing that, you can get a pretty decent adhesion with your paints and your fillers. But it's a heck of a job. And it's hard to clean. After you've bead blasted it, you've got to get it absolutely clean. You cannot have all that glass beads all over there. You need to either vacuum it with a real good vacuum, or blow it off with 100 psi or something, or wash it down with soap and water, I don't know, but you need to get that out of there. It's not a real super way for everybody to do. If you have the capability, do some test samples and see how it works out. You do get better adhesion because you're bead blasting every little thousandth of an inch is roughed up.
Okay, this board is more what we're doing now. The last Canards have been done more this way, where we sand it, put on the West system, sand the West system with, we're 40 grit here, West system with 100 grit, Morton's Eliminator up to 180, and then 1 quick coat of the 131 as a UV barrier, and paint on top of that. That is more the preference of what we like right now. A lot of these systems will work. This is just what we're using right now in the shop. We keep changing materials. Another thing that will be up here for you to look at later is I've done a sample board of the different filler materials. Okay, and the filler materials are the ones that I've covered up on the chart there. We've got the West epoxy using as a filler material. This is using it to fill the weave. Evercoat is something that we have just tried on test samples. We've never used it on the airplane. It looks good, but we don't have any long-term experience with it. We show you how we sand for finish. Morton's Eliminator, Polylux is another one in the same category. There seems to be a proliferation of these products coming out on the market. It's hard for us to keep up with testing all of them. Sterling, most of you guys are familiar with that. I've sanded the 100 grit across the bottom. We'll put some 100 grit sandpaper out here and you can come up and scuff up a little area. Leave some for the next guy to do too. We'll put that out.
Okay, all of these samples will be up here for you to look at. And these boards that Michael has filled out up here that are pinned up on the wall give you our opinion of what they are like to sand, what they are like as adhesive materials. You can read off everything and make your own judgment on that. As an example, what Burt has always done, from way back on the very big and very easy and on through to the long easy, his preference and what is written in the plans is build it out of safety epoxy, sand that. If you're within the tolerance that the plans calls out, you go right into feather fill. Feather fill is just like Morton's Eliminator or Evercoat. It's a polyester-based material. You can mix some micro balloons with any of those, or you can paint them on pure. The build will be smaller if you don't have micro balloons. From there, he goes to what he used to call 70S. We don't use 70S anymore because you don't get real good adhesion to it with the top coat. We went into 100S. They stopped making 100S. Now we recommend 131S. That's a DuPont product. On top of that, he used on his Defiant and on his Long Easy Centauri acrylic enamel. Mike Dilley's choice, if he's building his own airplane and not like on the Solitaire, which he did, he likes to go from the safety epoxy structure into the West system micro balloons to build up the contour and get it perfect. Then he likes to go into Sterling. Sterling is a urethane-based material, 2-part urethane, and has very, very good adhesive properties. And it cures extremely rapidly. So it has a couple of advantages. It sticks like, you know what, to an army blanket. And you can sand it within an hour or an hour and a half, which is a lot of them you can't do that. The problem it has that I don't like about it is that it does have a propensity to develop pinholes. Urethanes cure by getting bubbles in them. It seems to me that's how they work out. On top of that, he'd fill the pinholes with spot putty. Then he goes into Ditzler's Crete 33, which is the equivalent of DuPont's 131S. It's a primer surface. On top of that, he likes to put Ditzler Durethane. Now, we are recommending that if you like Ditzler products, use Ditzler products from the epoxy micro out. Use all of their products. Don't use DuPont, Ditzler, something else. Use one manufacturer's, and if it fails, you can go back to him and say, what happened here? If you mix products, you're going to have problems. My own personal preference, and what I have on my airplane, is the West system on top of the safety epoxy structure, the Morton's Eliminator, which is just like feather fill, but I think it works nicer, 131S on top of Morton's, and Imron, DuPont's Imron on top of that. Now that is a DuPont system throughout. Ditzler has its advantages. Ditzler urethanes can be repaired. Imrons are difficult to repair. So that's what, for what it's worth, those are the three choices that we have. As you can see, we disagree on what to use, so I'm sure you people would disagree. But go out and use a reputable brand. Don't go out and get some oddball brand. I would go out and use Sherwin-Williams or Ditzler or DuPont or Sterling, someone that's a reputable paint manufacturer, and you'll be in good shape. Your ultraviolet barrier, remember, is primarily the top coat. It is not the 70S or the 100S or the 131S. That is not your primary ultraviolet barrier. That is a mistake. That is not true. The top coat is the ultraviolet barrier, and any reputable paint manufacturer's top coat paint will be an adequate ultraviolet barrier. Okay. That finishes up the finishing side of it, and as Michael said, we'd be willing to talk to anybody who wants to talk about it. We've made up some samples here to show you just how strong or how weak it is when you glue fiberglass to foam. This is urethane foam. This is what you make your very easy fuselage out of, your very easy center section spar box, the nose of your long easy and your very easy. Several places on the very long easy you're using this foam. Very soft stuff. You can dig your finger into it. It's real easy to carve. You can sand it to any shape you want. But it doesn't have real good adhesive peel qualities. The peel strength between fiberglass and urethane foam is zip, essentially. You can come up and look at that. That just looks like an unblemished piece of foam. This is Clark urethane foam. This is what is popularly used in surfboards in Hawaii and all over the place. And it is also a urethane dusty Canard. I was just sanding it last night. This here,
To try and answer some questions, we gave our basic opinion on the top coats over here. Around here, the company has been using DuPont products from day one. We've painted the Solitaire with Ditzler products, and the Voyager is painted with Ditzler. And I think if you're going with a good quality manufacturer and you use his primer top coat system, then it really isn't going to make very much difference which particular brand name you use. We've given questions as to what are the advantages and disadvantages of the top coat. No one top coat is the best for all things and for everybody. So you can't ask us which top coat should I put on, because it's not a cut and dry question. Look at the chart if you're going to paint your airplane still, and if you have further questions, we'll answer the best we can.
and this particular Canard is my own one for my own airplane. And the antenna you see here is what was called out in the last newsletter. I forget who manufactures it, but it is a super antenna. It's a foil antenna just like the one that's in the plans, except that it comes completely assembled with this little box, magic box in the middle. And it is some sort of an electronic whiz-bang that tunes the whole band. See, when you trim it to 24 inches, it's perfect at one frequency. As you move higher or lower on the frequency band, the antenna gets less and less efficient. This little whiz-bang here makes it just as efficient everywhere. And I have found on my own testing that antenna there stopped my needle wiggling around. It's just dead solid now, even from 100, 110 nautical miles out. So I'm getting real good tracking on the VOR antenna using that. Okay, the way this hinge is done, it's a there's very little hard points inside of the tube that's in the elevator. Anyone who's got the plans can see that. The plans are available. And there is a stainless steel pin that runs through on this elevator here. Has 3 hinge points, only 2 of which are outboard of the fuselage. There's only 2 hinges outboard of the fuselage instead of 4. On this side there's only 2 outboard, but there's only 2 hinges that have the pin. This pin is very short. This pin comes all the way to here. Now to get it out, there's a set screw in here that should be Loctited in when you get ready to go flying. I had it Loctited in. I broke it loose this morning because I didn't figure I'd be able to get it out. Boy, it was hard to get out, but it came out. That little set screw gets put in with Loctite. There's a little hole drilled in the end of the hinge pin. It's very hard for you to see that. But to pull this pin out, grab a hold of the elevator. I just used a spike or an awl. Start it out of there. Is the bolt out of the end? Okay, that takes the elevator off. So you can see you don't want that pin falling out. Inside this tube, there is a little machined pocket in the tube, and you get the tubes pre-machined if you buy the Brock parts. I don't know if he's here yet, but he was supposed to be here today with 50 kits to sell if anybody wants them. There's 3 pockets in this tube, and the hinge pins, the CS3s, or the equivalent of the CS3s, are just like they were before, only they're flat. And they have a little bushing in them. You slide that pin in and it pivots. It works very, very nicely. It's a little lower drag airfoil, and of course without the hinges hanging out, it's also a little lower drag. The airplane has a little bit more performance on the same airplane. I was able to measure a small increase. I wouldn't recommend that you go out and put this thing on just to try to get that small increase. I would frankly recommend that you go out, if you've already got your airplane flying, fly it in the rain. See what sort of a trim change you have. If you have a trim change that's not acceptable to you for one reason or another, that it pitches down and you're uncomfortable with it, build this Canard, you won't have that problem. If you have a perfectly adequate rain trim change and you're not unhappy with it, there's no reason for you to build this Canard. Your old Canard is a very adequate Canard. There are hundreds, 600 plus of those Canards flying. And very few of them have any problem. This is a higher technology Canard. Burt can tell you a little more about the airfoil. It took a lot of development.
Yeah, blunt ends on the front and the sharp ends on the back. It works every time.
Yeah, well, that really does conclude what we had here for the seminar part of it. If anyone would like to come up and ask us questions, we're happy to talk about anything that we were talking about. But we're also going to try to get some food down there.
This is January 8th,